Cool. There we go. Love it. All right. Yeah, let's go ahead and talk about these different answers that I see up here. So, first off, we need to mix things, right? So we need our ingredients and mixing them. So that's definitely step number one. We should preheat the oven, right? That can be around when you're doing your ingredients. So step number two. Sometimes step number one, right? Depending on how early you need to preheat it. Then we're going to go ahead and shove it in the oven, right? First, we can probably put it in a pan, right? So we probably want to put it in a pan first that's been um, lined with parchment paper and like nonstick stuff like oil and flour, and then shove it into an oven. Yes, I agree with that, right? So, and bake it. And then once we take it out, we want it to go ahead and cool, because once it cools, we can then do our decorations, right? So we can frost it. We can put sprinkles on it. We can put candles on it. My daughter, for her third birthday at her nona's house, had a cake that was a chocolate cake with pink frosting and blue candles, and now that's what she wants for every single birthday in the future. So we'll see if that keeps on happening. But she remembers that cake very vividly. I love it. All right, well, today we're going to go ahead and use a cake as an analogy of a chemical reaction. So hopefully you don't get too hungry during today's talk. But let's go ahead and start opening up our notes. Links are in the chat. Here is the 4A notes. We're starting a new unit here. Remember that you can get notes credit at any time throughout the trimester. They never really close. You can redo them up to 3 times. And as long as you use the recording, you should do really well on them. However, if you also want attendance, so both notes and attendance credit, remember that you do need to be doing your notes during class and actually passing them, because we give you enough answers to always pass them. Yeah, Eva, if you want to use yellow cake mix for your food project, that Unit 1 project, go for it. Sounds tasty. I feel like for your food project, you should definitely take advantage of making good food, because then you have a nice result after you do all that hard work. All right, everyone, let's go ahead and start raising our hands for our notes and go over our attendance in the meantime, or our announcements.
All right, guys. Happy Monday. Welcome to a new week. As always, please do not share any personal information during class. All right. We're going to require your participation as always. And these class next sessions are still being recorded for learning purposes. All right. We are at the brand new start of our week here, and also a brand new start to a new unit. This unit is going to be called stoichiometry. So stoichiometry, that all that big complicated word means is that it deals with the study of reactions, everything from what reactions do to what's in them, what results for them, the different types of reactions, how they behave, stuff like that. All right, but today we're going to get into the very basics of chemical reactions. So we're going to first define what a chemical reaction is. We're going to identify the components of a chemical reaction. That's why we took the time to explain like how a cake can be a chemical reaction, and we'll get to that later. And then we will explain the difference between endothermic and exothermic chemical reactions specifically. Okay, let's take our time. Let's use those links we have at the bottom of the chat. Again, if neither of those links work, you can always use your grades tab to directly access your notes anyway. All right. I'll give us a brief timer here.
All right, everyone. So just a quick announcement here. I am going to be going on maternity leave in 2 weeks. So on Monday, May 24th, and I will not be returning for the remainder of trimester 3. So I will be very sad to to say goodbye to y'all in just a couple weeks. But hopefully, if you're graduating, hopefully I'll be able to make it to the graduation ceremony. I actually don't know, Ezekiel. It is a surprise, which is what we also did with my daughter. So I did not know if she was a boy or a girl. Thank you. All right. So just to make sure that you all are squared away before I do leave, I am going to have office hours every single day for the next 2 weeks at 2 p.m. to help support you with your projects. Thank you, everyone, for the congratulations. I appreciate it. So I highly, highly recommend that you do have your projects submitted before I leave, just because I don't really know what's going on with the substitute situation. And so I don't want to leave anyone in the lurch. So whether you're enrolled as my student or Mr. Bengal's student, if you need help on those projects, definitely come to office hours. Really, again, I really recommend try to be as up to date as possible um, by May 24th. Just that way you know that I'm leaving and that you are in good shape when I leave, okay? Additionally, just so you know, the Unit 4 project is being replaced with the Unit 4 exam. The reason for that is just to make it grading easier for sub teachers, because again, I don't really know what the sub plan is. So I want to make sure that it's as easy for them to stay on top of grading and stuff for y'all. The final exam is unchanged. It'll still be a final exam. So that has not changed. But again, just so you know, no more projects. We have the Unit 1, 2, and 3 project. There will just be 2 more exams, and then the trimester will be over. So we have about 20 days left, and then the trimester's over. So crazy to think about. All right. So again, make sure you're coming to office hours if you need that. Take advantage of that extra help. All right, so what I want to know in the chat is, what do you think of when you hear the word reaction? Go ahead and tell me in the chat, what do you think of when you hear the word reaction? The word react means. Yeah, so it could mean like how you feel, could be an emotion, it could be being insightful, right? Having an insightful reaction, maybe a response. Yeah, an emoticon, right? Like on social media. It could be something like a response, screaming, crying, fainting. That's a very extreme reaction, I would feel like, right, Tara? Any other things you can think of? Yeah, reaction, you could feel curious, right? There are some examples of reactions down here. Any other things that you can think of when you hear the word reaction? Yeah, you could be laughing. Laughing is a type of reaction. Yeah, so today we're definitely going to be talking about chemical reactions, Matt. So, right, so chemicals, uh, right, mixing and changing, things being created, destroyed, definitely. Awesome. All right. Well, when we think about the word reaction, we should be thinking about something changes, right? So it's a response to something that happens and something changes, right? So in the same way, when we talk about chemical reactions, something is changing. So in a chemical reaction, the chemicals are changing. That's why it's a chemical reaction, because the chemicals are actually changing. So here are some. Software is removed. Oh, that's interesting. Weird, Eva. Sorry. So here are some examples of chemical reactions where the resulting chemicals are different. So an example is you can have different chemicals that come and bond together. So you can see right here, they start out separate, and then they actually come together, and you can see a little line between them showing that they are now bonded together. And again, this final result, even though it's made up of the same sort of ingredients here, is going to act differently, because once you have a bond happen, things are now chemically different, and so they have different chemical properties. You could also break those chemical bonds, right? So this is an example right here where you have a bond between 2 different substances, and then you go ahead and break it, and now you have separate things right here. And again, those separate things right there are going to act differently than what you started with, because chemicals have changed, and so they now have different properties. Or finally, bonds can also rearrange themselves. So you can see right here that this C is subbing in for this B here. Or you can see in this example, B and C are actually switching places. So all of these are examples of chemical reactions where what you end with is not chemically the same as what you started with, and now it acts different. Examples here are hydrogen and nitrogen reacting. So hydrogen is H2, nitrogen is N2, okay? And these are both gases. And when they react, they create ammonia. Ammonia being like the stuff that's in Windex, or eventually what your urine breaks down into. So that smell of Windex and broken down urine is very similar to each other, because they both have ammonia in them. So you can see here we have 3 hydrogen molecules. H2 is how hydrogen normally exists. So you have 2 atoms per molecule for a total of 6 hydrogens. And N2, nitrogen exists as N2, so that's 2 nitrogen atoms. And when they come together, they create 2 molecules of ammonia. And so what you end up with is the atoms are staying the same amounts, right? We still have 1, 2 nitrogen atoms. We still have 1, 2, 3, 4, 5, 6 hydrogen atoms, but now they've rearranged themselves and chemically they're going to act differently. Smiley faces, emojis in the chat if that makes sense. I agree, Windex smells horrible because it smells like broken down urine. It smells like ammonia. I agree. Yes, and make sure you don't mix it with bleach because you will make a very bad gas. Don't mix ammonia and bleach together. All right. So just so you know, when these chemical changes happen, heat is absorbed or released. So we are going to be taking a closer look at that vocab in just a moment at the end of the lesson. But just for now, number 2, what we need to know is that heat gets absorbed or released in a reaction. 20 seconds to fill in the blank with the word heat and only the word heat. Make sure you spell it correctly. Yeah, it makes mustard gas.
Okay, everyone. Yeah, so our whiteboard tools are on at the moment. So what we're going to do is that we're going to use our thin lines to match up our what we call terms and definitions together, but the definitions are kind of just like in terms of words describing what's happening. And our terms are actually like in a picture form, the type of reaction that we're dealing with. So either, right, the reactions are bonding together, they're being rearranged, or bonds are being broken. But one thing that I think you guys might not be used to looking at is how these general chemicals are behaving. So if they have a line between them, that means there is a bond, right? But if you have like something like A plus B, that just means that A and B are both separate substances or elements in the same container or environment, and they're either like in a mixture or in a solution together. All right, but they are not bonded. That's the key difference. They are not bonded with when there's a plus in the center. All right. But what I'm seeing so far is pretty good. I'm seeing Tara. Let's see, Rosa is up there. Let's get a couple more people participating. All right, we got Mesa up there. Adrian, awesome guys. Creek is up there. All right, let's go ahead and pause that and just confirm that, yes, we were being accurate with our responses. So just reviewing number 3 for a bit while you guys fill this in on your notes. The reaction at the top is showing bonds being broken. So A and B being bonded together. For some reason, they are losing their bonds and becoming separate substances, all right? And then in the center, we have bonds being rearranged, kind of like a dance routine where they're switching dance partners. A instead of with B is now bonded with C, and now C is being bonded, or I'm sorry, now, and then D is being bonded with B. All right, and then finally at the bottom is just the reverse of what's happening at the top, where now A and B are being bonded together to become a new chemical substance.
Sorry, you can't hear me. All right, let's go ahead and talk a little bit about how chemical reactions and physical changes are different from each other. So remember that during a chemical change or chemical reaction, this results in different chemicals being formed, right? So it's a chemical change, meaning that the chemicals are changing. Examples here are rust, fire, and carbon dioxide. No worries, Mallory. Rust, fire, and carbon dioxide bubbles being formed are all examples of different chemicals. Rust is iron oxide. Fire, right, creates carbon dioxide as well as water. And carbon dioxide bubbles are also a frequent indicator of a chemical change. Now, during physical changes, though, everything chemically stays the same. So, for example, ice, water, and steam, even if they change into each other, are all still chemically what? So whether we're freezing or boiling, tell me in the chat. This is all still chemically what? What letters and number combination represents the formula for water, ice, and steam? They're all still what? Thank you, Tara. Thank you, Rosa, Camila. Yeah, exactly. They are all still H2O. So chemically, they're all still identical. So again, this is not a chemical change. This would only be a physical change. A great example of a chemical change, an easy one that you can even do at home with parental permission, is baking soda and vinegar. When these mix together, they form something chemically different. So we start out with the chemical sodium bicarbonate and acetic acid. And what they do is once they do react, they change into different chemicals. We end up with carbon dioxide, CO2, water, H2O, and sodium acetate salt. So again, even though the actual atoms are all the same, they're being rearranged. And anytime we have a rearrangement of those bonds, a rearrangement of what things are attached to each other, that is a chemical change. These final substances are going to act differently than their initial substances. Just so you know, sodium acetate salt is the flavoring of salt and vinegar chips. So tell me in the chat if you like those or if you hate them. They're definitely, I feel like, a polarizing type of chip. But yeah, salt and vinegar chips come from sodium acetate salt, that flavor. Yeah. Yeah, I like them in very small amounts, but in large amounts, they kind of make my mouth and my stomach hurt. Excellent. This is number 4. Go ahead and fill in the blank with the word physical, only the word physical. 20 seconds to raise your hands. Go, go, go.
All right, so practicing chemical changes. So all these responses listed here, there's 6 of them. They're either going to describe correctly a type or result of a chemical change, or it's going to be incorrect. So let's use our whiteboard tools, which are on right now. Put a box, be sure to make your lines thin, but place a box around the response that you believe is accurate for describing a chemical change. All right, you might notice that they're somewhat organized into general categories. The responses with the blue words are describing bonds that are happening, either they're staying the same or being broken or reformed. The pink are dealing with substances, and the green are kind of like real life examples. So yeah, you can either place a box around like the whole like phrase, or you can do a circle or a check mark like I'm seeing. It's just that the smaller the drawing, the harder it is to click on and see who's participating. So I'm seeing Alyssa up there, Rosa, Shane is up there, awesome. Creek, Sophia. All right, it's looking pretty good up there, everyone. So let's go ahead and pause that and review it for number 5. So yeah, this is going to go in your notes for number 5. Just reviewing a little bit. Yes, so the correct answer for each category is that, yeah, bonds in a chemical reaction are being broken, formed, or rearranged. Always, if you have a bond that's staying the same, usually it's something that is like the medium in which the reaction is happening. Like a lot of times you'll have a reaction that's happening in water, but water isn't directly playing a role in the reaction. But you have to have at least one bond that's being broken, formed, or changed somehow in a chemical reaction. With the pink category, we have, yeah, different chemical substances are formed definitely at the end, right? Kind of like with the baking soda and vinegar example, right? We're having carbon dioxide where we didn't have any before, right? Right. And with freezing liquid water, again, we're not breaking the bonds of water, and we're just changing liquid into solid with that example. So great job, everyone. Let's be sure we're raising our hands. I'll start a timer again.
So chemical reactions have what you start with and what you end with. We've already kind of seen that here, but now let's go ahead and add vocab into that. So what you start with, that's actually called reactants, and what you end with, that's actually called products. The way I remember this is reactants are the ones that do the reaction. They're the ones that react, right? So reactants are needed for the reaction. So therefore, they're what you have to start out with. Products, on the other hand, the way I remember that is if you think about a factory and how a factory produces a final product, okay? So that's another way to remember that. Go ahead and give me a smiley face emoji in the chat box if that memory trick helps you with that. If that memory trick helps you with that. Great. All right, so we're going to go ahead and talk a little bit about an analogy here. Eventually, you'll see these a little bit more in action when we talk about real reactions. But an analogy is just when two things are not exactly the same, but they have some similarities that help us to better understand something. So in this case, we're going to talk back about our cake example that we discussed at the start of class. That's going to be our analogy. Now, in reality, there are chemical reactions happening when you're baking a cake, but it's actually many chemical reactions, whereas here we're just going to pretend that it's one. Okay, so that's where the analogy part comes in. So in our analogy, we mixed batter ingredients, then we introduced heat from an oven to bake it, and this resulted in a cake. So tell me in the chat, ingredients, are those more like the reactants, what we start with, or the products, what we end with? Go ahead and tell me in the chat, what are the ingredients like? All right, first think to yourself, the ingredients, is that what I start with? or is that what I end with? If it's what you start with, that should be the reactants. If it's what you end with, that should be the products. Go ahead and tell me in the chat. Thank you, Tara. Thank you, Eva. Thank you, Adrian. Let's get some more answers. Thank you, Sophia. Yeah, again, ingredients are what you actually start with. So these are going to be more like the reactants in a chemical reaction. So then baking is like the actual reaction. Again, reactants are the ones that react. So they undergo the reaction. And then finally, the cake is like the what? Tell me in the chat. The result here, the cake is going to be more like the what? Think about, is it what you start with, what you end with? And therefore, what's that vocab word? Yeah, this is going to be more like the product because this is what you actually end with. It is the final product. All right, so we're going to continue taking a look at this example here using another vocab word, which is the limiting reactant. Now, again, reactants we just said are what we start with. Okay. But sometimes you have the wrong amount of ingredients at home. And in the same way, chemical reactions, sometimes you have the wrong amount of reactants. So in that case, if one reactant gets completely used up first, then the reaction can no longer continue. And so that limits the amount of product we can make, hence where that word limiting comes from. So for example, in our analogy, if you run out of flour, or if you run out of eggs or sugar or butter or milk, then in that case, you can no longer make any more cakes, right? As soon as you run out of one ingredient, your cake recipe can no longer be made. Smiley faces, emojis in the chat if you understand. Doesn't matter how much flour you have, if you don't have enough sugar, you cannot make a cake. And the sugar in that case would be your limiting reactant. Okay, cool. So let's go ahead and actually apply this to our analogy. So we have a cake recipe. Which is 1 cup of butter, 2 cups of sugar, 3 cups of flour, and 4 eggs. I think this would probably make a pretty nasty cake, so don't actually try this at home. But let's just pretend that this makes a really delicious cake, okay? So we're going to take a look at what we have in our cupboard, in our pantry, and we're going to pretend this is how much of each ingredient I have. Based on that ingredient alone, how many cakes can I make? And then we'll finally take a look at, based on all the ingredients I have, what is my final limiting reactant? So if I'm just looking at the cups of butter, let's imagine I've got 4 cups of butter, and the cake requires 1 cup of butter, then just thinking about butter, how many cakes could I make? Tell me in the chat. If I have 4 cups, divided by 1 cup per cake, how many cakes could I end up with? Go ahead and tell me in the chat. Again, ignoring everything else, assuming we have enough of everything else. Yeah, in this case, 4 divided by 1, we should end up with 4 cakes. Let's go ahead and try our other ingredients. Again, just paying attention to the ingredient by itself first.
Okay, so now looking just at the sugar, right? So if we have 10 cups of sugar and the recipe calls for 2 cups of sugar per cake, right? That's the important part, per cake, right? We can actually turn this into a math problem. So if I have 10 total and we want to see how many cakes we can make, so per cake is 2 cups. That's actually 10 divided by 2, which is going to equal what number? All right, Tara and Ezekiel, you guys are on it. Kind of some little more participation. Yeah, exactly. Rosa, Creek, Umeza, Sophia, awesome. Yeah, so this is going to make 5 cakes. All right, so let's look at our next ingredient.
Okay, so same thing here, just paying attention to flour. If I have 9 cups of flour and my cake requires 3 cups of flour, then how many cakes could I make? So 9 divided by 3, how many cakes could I possibly end up with here, just paying attention to flour? 9 divided by 3. Again, pretending you have enough of everything else. Yeah, in this case, we would end up with 3 cakes. Awesome. All right, let's take a look at our last ingredient.
All right, so with eggs, right? So we've been through this before. If we have 8 eggs total and we call for 4 eggs per cake, that is 8 divided by 4. And that is going to equal what number? A lot of people already have the answer. Awesome. Yeah, so exactly. It's going to be 2 cakes. So now we're going to put it all together. And the ingredients that is going to run out first is going to be known as our limiting reactant.
All right, so let's think about that. We had 4 cups of butter can make 4 cakes, 10 cups of sugar can make 5 cakes, 9 cups of flour can make 3 cakes, 8 eggs can make 2 cakes. So tell me in the chat, which thing will I run out of first? Which thing will I run out of first? Am I going to run out of butter, sugar, flour, or eggs first? Go ahead and tell me in the chat. Think about which of these makes the least amount of cakes. Yeah, you run out of eggs first. Absolutely. So we run out of our 8 eggs first. All right. And at that point, we've only made how many cakes? How many cakes can we actually make before we start running out of stuff? Yeah, if you see here, right, our 8 eggs are our limiting reactant, and we can only make 2 cakes. It doesn't matter that we have all the other ingredients that could make more cakes, right? If you run out of one of your ingredients, then you literally cannot make the same product anymore. So that is why our eggs are the limiting reactant. This is going to be the answer to number 6 and number 7. Go ahead and raise your hands when you have this saved. You have 30 seconds to answer both of those. Go, go, go. Raise your hands. All right, we're just waiting on raised hands. Paul, 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 Thomas, Thomas, Ezekiel, Ezekiel, Fernando, Fernando, Jen, 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 Eva, 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 Umeza, Umeza, Antoinette, Antoinette, Gino, 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 Dane, 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 press, press, press. And I do see Camila in the chat. So Thomas, Eva, Preston. Thomas, 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 Eva, 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 press, press, press. Go ahead and raise your hands for number 6 and number 7, or communicate with me in the chat. Okay, so last thing we want to talk about is just that, remember that chemical reactions can either release or absorb heat. Remember, this is called exothermic versus endothermic reactions. So exothermic reactions release heat. A good way to remember this is exo means what? What does the prefix exo look like? What does the prefix exo look like? Let's focus in the chat, please. What does the prefix exo look like? Yeah, it looks like the word exit. So in this case, heat exits. And if heat is being released and exiting, that means that it actually feels hot. So these are hot reactions, right, where energy that's stored in our reactants gets released, causing the product to feel hot. An example here is sodium and bromine can react very violently to produce heat and light, as well as they form a different chemical, sodium bromide, which is now stable and will have different properties than the sodium and bromine by themselves. Endothermic, on the other hand, means that reactions absorb heat. The way you can remember this is endo looks like what word? Endo looks like what word? Yeah, endo looks like heat enters. Exactly. So if heat enters, this is the opposite. These reactions actually feel cold. So in this case, they're absorbing heat and the products feel cold. The way you can remember this is it's more like the reaction is actually stealing heat, right? So you can imagine it's like stealing heat from the environment, and that's why it actually ends up feeling cold. So here's a cool reaction of this. We have ammonia thiocyanate and barium hydroxide reacting, and they actually react and they absorb so much heat that they actually freeze the beaker. So I do have a link to that video in the chat. I don't have time to play it right now, but it's a pretty cool, cool reaction to take a look at in more than one ways. It's cool because it's awesome, but also it's cool because it's actually a cold reaction. All right, let's make sure that you understand these. At this point, you should be able to match these all up, and I'm going to go ahead and let Mr. Bangle take over.
All right, so let's go ahead and do some matching, but this is going to be matching on our own. So just make sure that you are doing this kind of like on your own scratch sheet of paper if you need like a visual aid. All right, please don't share any answers in the chat. And if you have any questions, we will be in the Q&A. All right, but otherwise, I'll give us an extended timer for us to complete this. It's just, the terms are just the general terms that we've been learning this entire lesson, like reactant, product, limiting reactant, the ones we just did with exo and endothermic reactions, right? And we'll match those up with our definitions of those, and we even give you some hints along the way as well in there. Just reviewing what we did, we learned all about chemical reactions, defining them, looking at their components, and explaining the difference between when heat is absorbed and released. Go ahead and just really quick, if you want, tell us how you feel. Do we feel awesome, or do we still need some help? Just a reminder, if you still need help, you do have an optional office hours between the hours of 2 and 2:30 this afternoon. All right, so keep that in mind if you need any assistance, but it looks like we're all doing pretty awesome today. So if you haven't already, please submit your notes. Yeah, let's go ahead, and if you don't have any questions, feel free to let yourselves out of the class. Have a great day, everyone. We'll see you guys tomorrow. All right, if you have any questions, just stick around.